Welcome to our introduction to solving a system of equations. In this lesson, we are going to define what a system of equations is and explore the different possible solutions for a system. This will provide a base of knowledge you will need to solve a system of equations in one of three ways: graphing, elimination, or substitution. Before we try to solve a system of equations, we need to define what one is. A system of equations is a set of two or more equations that are relations of two or more variables. As you can see, there are many variations of the kinds of equations that can be used to make a system. We can have three linear equations in three dimensions. A mixture of linear and quadratic equations is possible as well. In this lesson, and throughout our lessons, we are going to explore how to solve systems of two-dimensional linear equations like the ones here. So what are we really looking for when we're solving a system of equations? We want the value of each variable that will make both equations true. These values will give us the coordinates of a single point that is on both lines. In other words, they give us the point where the lines intersect. For example, if we were to look at the lines y equals negative 1/3 x minus 1 and y equals 2/3 x minus 4 on a graph, we can see that they appear to intersect at the point 3, negative 2. Note, however, that this method of solving systems is only an estimate until we confirm the solution algebraically. In this case, x equals 3 and y equals 2 are the values that appear to make both equations true. Notice that if we substitute 3 for x into each equation, y equals negative 2 in both. This confirms that 3, negative 2 is our solution. So what are the possible solutions for a system of linear equations? There are actually three. The first and most common possibility is when the two lines intersect at a point, as we saw before. The second possibility is that the lines are parallel. There is no solution because the lines do not intersect. We call this system inconsistent because the equations do not have a common solution. The third possibility is that the two equations actually represent the same line. There are an infinite number of solutions. This system is consistent because we do get valid solutions, just not one solution. We can say these lines coincide, or they are coincident lines. Now that you know the basics about systems of equations, you can move on to our next lesson on solving systems by graphing.